All right, so this is what we have so far. We have a counter counting up. I just want to change this to be an FPS instead. So my counter variable, which I declared earlier up here, is starting at 0, and I'm just adding 10 to it every frame. Instead of adding 10 to it every frame, if I just take 1 divided by delta time, that's my FPS. So right here, this represents 1 divided by how much time has passed between the last time I called the loop. So you get an FPS display that is counting up really fast. But this represents our FPS. So you can see 991 FPS, 2500 FPS here, 4600 FPS. You can stick this guy up here in the top left corner, like so. Oh, I didn't move him correctly. I just want him up in the top left corner so that he can draw, he can act like an FPS display, right? Cool. And then right below him, I want to set up something that shows the mouse position. One thing to keep in mind, if you don't set the position or the origin or the character size, these all have defaults. So in this case, the only thing I'm setting, I'm not even setting the string. The only thing I'm setting on my text is the font. That's it. And if you just do that, you just set the font, it's going to default to being at 00 and being white. So if I create another text variable here, I'm going to create another one for my mouse position. And this one I'm just going to move slightly down, maybe 50. Same idea as this. So what I can do here is I have a bunch of work here for my FPS. If I just set the string to be, I don't know, like I want to look like this, just to prove that it's going to draw something. I always like to put a little bit, just add a little bit of test code to make sure that it can draw. And see how it's not drawing there because I forgot to add the draw call. So before I get too far, I want to make sure that I actually can draw. So there's my mouse position as a string. So what I'm going to do is I'm going to do the same thing. I can create another string for my mouse string, my mouse SS. String. And I'm going to dump into it the little string that I made. So I'm going to do this. I'm going to get SF mouse get position based on window.x. It's a long thing to write, but it basically is in the SF namespace, get the mouse, call get position, pass in the window, so I get the position relative to the window, and then from there pull x. I'm going to inject a comma in the string, and I'm going to do that again for y, and then put a bracket here. This really big line is basically just to get the x and y position. And if you want to, you can also make a variable that does this. And this will make it a little bit simpler, so you can just do this and this. And then once you have that inside your string stream, you just call setString. And call the stir function on it. And then you draw it. And this, all this put together will now get you a position for where your mouse is. Go to bottom right corner, should be like 1024 by 512, something around there, and 00 on the top left. Okay. So based on this behavior, what I'm going to ask you to do for homework is I want you to implement the concept of score in Pong, and using string streams and using text and fonts, draw the scores on top of the screen for Pong. Same idea. Same idea as this, except instead of drawing the mouse X and Y position, I just want to draw the scores for player 1 and player 2. All right. Okay, let's spend a little bit of time going over audio. Because audio is another big part of games, and it takes games from being something that is kind of lifeless and turns it into something more interactive, and also adds a lot of feedback to the player, makes it feel better to play with those things. All right. So normally, anytime that you're looking for how to actually implement something, again, I would just Google SFML. This is like the biggest thing. I'm going to go over this together. But audio works very similar to how fonts work and how similar to textures work, because textures are files that live on disk. Fonts are files that live on disk, right? If you load a texture, you need to shove it into a sprite. If you load a font, you need to shove the font into a text. And sound is no different. Sound has a file that you're going to load onto disk into what's called a sound buffer. And a buffer is just a place to put stuff into, and it just means, hey, I want to load a sound file off disk. SFML supports like WAV files and OGG. They do not support MP3 files, but I did include in the audio folder two files, one for music and one for sounds. So there's this one sound here. I don't know. So this is actually a jump sound, which I'm going to show you guys how to make, as well as a song. If you guys recognize this, this is the overtime music in Overwatch. So we're going to play both of these things, and we're going to play the jump when we press a key, and we're going to play the music right when our game starts. Okay? Music and sounds are actually different things. Sounds are typically, hey, I'm going to load the whole sound when the game starts, and I'm just going to play it whenever I need to. Music can sometimes be really long. You might have like a 30-minute music file, who knows. The reason why music is different is because typically you'll load only a little bit of music at a time. You'll load whatever piece of music you're currently playing, only a little bit, so that you don't use up so much memory. So first things first is we're going to figure out how to actually make sounds. Whenever you get into game development, there's a big, you have to keep in mind like royalties and licenses for sounds. You need to make sure that whatever sounds and music you're using are actually, it's okay to use that in your game, because a lot of times they're licensed and you can't technically legally like use them, which is why I like to use this program called BFXR. And BFXR is a web-based version of SFXR, which is, you can download it. And this was made for game jams, specifically for a game jam called Ludum Dare. And these are great because what it is a procedurally generated sound maker. And on the left here, whenever you load BFXR, you'll see all these kind of presets for the types of sounds you want to make. So if I want to make like a, let's say I want to make like a pickup, or like a coin, every time you click on it, it makes a random sound. Or like an explosion, or a power-up. You can take these, like maybe, I like this one. You can take any of these, and you can mutate it. Or you can adjust. So you can use these to make sounds for your game. And these are all obviously free to use because you generated them. So I like to make like a jump sound. Maybe I like that one. You can make them sound more 8-bit like this, or make it more. Right? You can change the So once you have a sound that you like, you can click this button, Export Wave, and it'll just create a WAV file wherever you want to save it to. So it creates it on my desktop here. So I'm just going to grab this jump 4, and I'm going to put it into my audio folder. So let's figure out how to actually play this sound, okay? So as I mentioned, sounds use buffers, and they need something to put that buffer into. So the first thing you need to do is create a buffer and then load that file. So there's something called a sound. You will need to go up to here. One more thing is the first time we'll add a new header for SFML. There's an audio.hpp file. You'll include that at the top. Once you've included that, now in SF namespace there's a new type of variable you can create called a sound buffer. I'm going to call this one my jump buffer, and it's going to have exact same if statement, if jump buffer, load from file, and you're going to pass in the path to the file. And I happen to know that's called jump4.wave. So it's jump buffer, just like a font and just like a texture, right? These things all load kind of the same way. It's just called a sound buffer. Once you have a sound buffer, you need a place to put that, which is just like how a text is a place to put the font. There's just something called an SF sound. And jump sound just takes a set buffer and you pass in a buffer that you loaded earlier. This pattern is very similar to sprites and textures and also similar to text and font, right? So there's our jump sound. If you want this thing to play now, all you do is you figure out when do you want this thing to play. So in my case here, I want this thing to play when I hit spacebar. So if the event type is equal to key press, this is just like how we do all the other events. And if the event.key code is equal to spacebar, you take your jump sound and you call play on it. Okay? Play is a function that only works on sounds. It does not work on sound buffers. All right? This right here is how you're going to play sounds from your game. And I'm missing something. Open AL32. We're missing one thing, which is a DLL. I will need to give you guys this DLL too. I didn't realize these machines did not have it, which is not actually good.
These machines don't have anything that we need?
Yeah, it's because it doesn't have... I'm going to give you guys a DLL here in just a second.
Could you get one, like the ones like first blood, second kill?
You could do that too. Oh, you know what? It's actually in here. So if you guys aren't hearing sounds, or if you're getting a problem, I want you guys to all go into your folder for SDVA engine. There is an engine folder, and there's an SFML 2.3.2 folder. I want you to go into that SFML 2.3.2 folder, go into the bin directory here. See how there's an open AL32.dll? I want you guys to copy that. And we're going to go up into the engine folder now, go into this x64 directory, and release. We're just going to paste it right next to the executable here, like so. Once you have that, you can now play this sound whenever you want to. I happen to have two jump sounds. I'll drop it into your engine folder, go into x64, and then release, and put it right here, right next to this exe. So make sure you grab this OpenAL32 and then put it inside engine, x64, release, and then paste it here. So I want everyone to get a jump sound working and then we'll jump into music.